Alrighty, I'm going to try to make this as brief as possible. Hi, my name is Sven. I'm Mr. Olson's son, and I am working on a car at the moment. Actually, my truck. So, here I have an image I found on Google, which is very helpful, that's kind of explaining what the problem is that I'm trying to solve with my part that I'm making. So, if you look at this engine bay right here, you can see this is the intake manifold for the truck. That means that air comes in here to the engine. Now the important thing is this big hose here that comes right across here goes into this box, and what happens is this box is very important to making the engine run because it tells the computer how much air is coming into the engine. So it needs that in order to decide how much fuel to give it. This is very important in fuel injection cars. Basically, anything newer than 85-ish is going to be fuel injected. Now, the important thing to know is if you're looking at a carbureted vehicle like this one that I also built, this one has a carburetor right here on top. This is doing the same thing except it doesn't need a sensor. There's no electrical going on. It's very simple. However, in an EFI vehicle, you need this big hose and you need this big sensor here to tell the computer how much fuel to put in the engine. The reason I'm doing all this is because recently I had to tear apart my whole truck. So you can see the engine here is basically almost torn apart. Later on, we got to the point where I actually got the cylinder head off and the timing chain. It's not super important to know all these about these parts, but point is, I was replacing a lot of things, and ultimately, in the process of replacing a lot of parts, you want to deal with everything as you go. You don't want to come back later and deal with something that you could have had easier done. So, this is the air fuel measuring device, otherwise known as an AFM or mass airflow sensor, depends on who you talk to, but this part here is the part that has a little door in it, and depending on the amount of air that's coming through it like this, right? It's coming through from inside this side, it's coming out that way. And depending on how much that flap opens up inside here, it will tell these pins what numbers to give out, and basically it just tells the computer what to say. Again, if you want to go over where that was, it was right over here. Air filter box is right on top of it in the OEM location. And there's that. Now, the interesting thing that you can do on vehicles that you've designed is you can redesign them. And what I want to do with this is I want to actually shorten this hose. Because the shorter I make this hose, the more efficient the air getting into the engine will be. The shorter it has to travel. In addition, the hole that this actually comes out of is very small. It's about 4 inches by 2 inches, if you imagine a rectangle. That's the hole that all the air that goes into the engine has to fit inside. So it's a very small area. It's trying to suck a lot of air through that, and it's being very difficult. So if we can give it a bigger air filter, which is a little bit out of frame here, but if you can give it a bigger air filter and a shorter distance to travel, it'll make the engine run a lot better, and ultimately you'll get a faster vehicle with more horsepower, which is nice because on an old truck like this, I'm fighting for the little horsepower I have. So this is basically the inspiration of what we're doing. This you can see a little bit out of frame. This is going to be a big air filter right here, like you can see on race cars and stuff like that. This is that AFM that we looked at just a couple of seconds ago. It looks like that, right? It's the same thing. It's just over here now. Instead of where it was before on the right side, it's moved to the left side. And this is good because you can get cleaner air from this side as well. So you've got cleaner air coming in here, more air coming in through here, and it's got a shorter way to go into the intake manifold here. This is the intake manifold. So this part here is just a normal stainless steel tube, not too complicated with some hose clamps on it. We're not worried about that. The problem is on this side of the air filter, or the mass air sensor, it looks like this. This is not like this end. This end you can fit a filter on very easily. This end you can't. So what I wanted to do was design a adapter to go from this to a standard cold air intake air filter. And what I did was I took the gasket, which this is the actual gasket of my truck, that fits on this face here, and I measured it very carefully with a set of calipers, and I came up with this sketch. This is an Autodesk Inventor, which you guys don't use very much, I think, but you can do this in pretty much any program. You just draw it out like this first, and it makes it a little easier to think everything out. And basically what I did here was I took the original holes, see these 4 holes here, 1, 2, 3, 4. that are here, 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 and here. And I marked out where that square is. See the square? It's like faintly behind the circle right there. And that's the actual square that's in the middle of this gasket as well. And then what I did was I made a big circle. And I made some other adaptations as well, which I can talk about in just a second. So this is what I ended up making. As you can see, it doesn't look exactly the same as what was on the back of the AFM before. It's got a couple differences. Obviously, these are actually raised up. There's a big hole in the middle. This big hole in the middle is intended that a cold air intake air filter will just slide on top of it. You can see how it's just sticking out a lot. So the diameter of this is actually 2.5 inches, which is a standard size. I designed that way on purpose so I could use it with any universal size. Now the nice thing about that is in the future, if I ever want to change the air filter, I could just go to a normal parts store and say, hey, I want an air filter for a 2.5 inch diameter pipe, and they can give it to me, which is cool. The other thing I did was I built out the shoulder a little bit on this hole right here. I can't actually go back to the screen, but you can imagine it was just straight across here before. I gave it a little more shoulder. That way the bolt had a little bit more to grip onto. One thing about 3D printing and PLA is that you always have to keep in mind it's not as strong as metal. So at least in my field, that's something you have to keep in mind because it's pretty dangerous. So I try to give it a little bit more shoulder, a little bit more thickness on top, try to give it a little chamfer so that eventually whatever is supporting on that face will be pushed down towards the rest of them. These are just kind of things you want to think about as you're building something or designing something to be printed is how is it going to hold up in the long run? What can I do to make it last longer? And if it's going to fix the problem for a long time, you don't want to fail on you. So the other thing I did, not so much for a 3D printing thing, but as a air filter thing, this chamfer here, I'm going to try to see if I can give you a better view of it. It's just a little bit of chamfer going down into the hole. And what that's for is as air is coming in here, I did not want it getting caught on a ridge. Because remember, the hose for the filter is going to go around the outside of it, right? Which means that this inside part is where all the air is going to go. So the air is going to come in here and it's going to get stopped immediately. I didn't really want that to happen. So I gave it a little bit of chamfer. I did not make it a full point, although I did think about it. If I made it a full point, then you're worried about layer adhesion. So you got to think always about how is this going to print. Is it going to print nicely? Is it going to print not nicely? So if it's a nice smooth circle without a lot of sides, that's something you have to deal with in SketchUp a lot. It's how many sides the circle has. In Inventor, it's not such a big deal. But you want to make sure that you have the right number of sides and that you're not going too thin. If I went too thin here, we would be down to 1 or 2 strands of filament going all the way around here, which is not stable enough to hold it up. So that's why I avoided that. And yeah, that pretty much covers it. I'm excited to see how it prints out and see if it works all right. If it does, I'll keep you guys updated. I'll send you a picture of it in the truck once it's finally done. But yeah. All right. Well, thank you so much for listening to me. Have a good day.